Our next section is molarity and dilution, which is numbered 19 through 21 in your notes. Okay, so look at number 19. Determine the molarity of a solution made by dissolving 120 grams of NaOH in enough water to make 2 liters of solution. So the first thing we need to know is, what is molarity? Well, molarity is just a unit of concentration, represented by a capital M, which is equal to the number of moles of solute divided by the number of liters of solution. So that's the total whole solution. So it's easier to kind of shorten that to moles per liter. So we're going to have to look back at this problem and take that 120 grams and turn that into moles, and the 2 liters, and that'll be liters. So our first step is 120 grams. Now since this is NaOH, off the periodic table I have 23.0 plus 16.0 plus 1.0, which is equal to 40.0. So 40.0 grams for every 1 mole gives me 3 moles. So then my molarity formula becomes 3 moles divided by 2 liters is equal to 1.5 m. Okay, let's look at the next problem. Number 20. How many grams of KNO3 are required to make 500 milliliters of a 0.500 molar solution? So molarity is moles divided by liters, but notice that this is 500 milliliters, so that's going to have to convert to liters before I can do anything else. I'm also going to take this 0.50 and plug that in for molarity. So, to convert milliliters to liters, there are 1,000 milliliters in every 1 liter. Gives me 0.5, so I'll plug in 0.5 right here. Now when you're solving a problem like that, over 1 we're going to cross multiply, so that's 0.5 times 0.5, which gives you 0.25 moles, which would be fine if we were looking for moles, but the final answer asks for grams of KNO3. So now I need to know the molar mass of KNO3 off the periodic table. Potassium is 39.1 grams, plus nitrogen is 14.0, plus oxygen is 3 times 16.0, which is 48. Add those all together and we get 101.1 grams per mole. So, going back up to this mole problem, 1 mole is 101.1 grams. 0.25 times 101.1 is 25.3 grams of KNO3. So if we were actually making this solution, we would add 25.3 grams of KNO3 to enough water to make 500 milliliters total of solution, and the solution would then be a 0.500 molar. Number 21. Now this time it's a little bit different and we're looking for a different formula because we're diluting. Describe the preparation of a 1 liter of a 1 molar HCl from 2 molar HCl. So the formula for dilution is M1V1 equals M2V2. And what this actually does, the M1V1 is molarity times volume, so that'll find the moles of one is equal to the moles of another. Plugging in the numbers from the problem, I have 1 molar times 1 liter is equal to 2 molar times X. Divide both sides by 2 molar so that it cancels, and I end up with X equals 0.5 liters. Now we'd be finished there if it was just asking how many liters, but it's not asking just how many liters. This time it's asking describe the preparation of. So how would you prepare a solution? So here we go. We're going to add 500 milliliters, which is the same thing as 0.5 liters, of 2.0 molar HCl to enough distilled water to make 1 liter of solution. Okay, so what this means, this 0.5 liters, is how much of the 2 molar solution we're going to need total to make the 1 liter of solution. So that's why we're adding 500 milliliters of that 0.2 molar HCl. We're not necessarily going to add 500 milliliters of water because the volumes may or may not be additive, but we are going to add it to make a 1 liter total solution. Okay, the last one, the same formula. Describe the preparation of 250 milliliters of 0.5 molar from a 6 molar stock solution of some unknown thing. And so if my formula is M1V1 equals M2V2, so my molarity 1 is 0.5 molar, my volume 1 is 250 milliliters, my molarity 2 is 6 molar, my volume 2 is X. So if we divide both sides by 6 molar, then the 6's cancel, the molars cancel, and we are left with X is equal to 20.8 milliliters. Don't worry that we have milliliters here because the molarities cancel, so it's okay to have a volume unit in milliliters. So describe the preparation of would be to add 20.8 milliliters of the 6 molar stock solution to enough distilled water to make a total volume of 250 milliliters. So that is how to make the solution. 20.8 milliliters of the stock solution to a total volume of 250 milliliters, probably in a volumetric flask, possibly in a graduated cylinder. It depends on what you have available.